Okay, we're on video 10 in the series about graphing equations. So the previous video, we talked about finding equations. And so what we're going to do in this particular video is we're going to talk about parallel and perpendicular lines. So what that means as far as equations for lines goes, how to determine if two lines are parallel, perpendicular, or also if two lines are just two random lines. But we're also going to look at how to find equations of lines parallel to other lines. So I could say, what is the equation of the line that's parallel to this one but goes through this point? So it kind of ties into the last video a bit. All right, so let's get started. So for this one, we have parallel and perpendicular lines. So we'll kind of look at parallel lines first, then we will look at perpendicular lines. We'll then look to determine if two lines are parallel, perpendicular, neither. And then, like I said, we'll wrap up by finding equations of lines involving parallel lines and perpendicular lines. Okay, so first of all, let's talk about parallel lines. Two lines are said to be parallel if they have the same slope but different y-intercepts. Now, in case you don't recall that parallel lines are two lines that never intersect. So in case you forgot that basic piece of information, just remember two lines are parallel if they never intersect. As far as linear equations in two variables is concerned, two lines are said to be parallel if they have the same slope but different y-intercepts. Okay. Now, on the other hand, two lines are said to be perpendicular if their slopes are opposite reciprocals of each other. So what I mean by opposite reciprocals, opposite just means change the sign. Reciprocal just means write the fraction upside down. So if I have m is 2/3, the slope of a line parallel to that would be -3/2. Okay, so you make sure your slope is in fraction form. You flip the fraction, you change the sign. Now, in case you forgot, recall that perpendicular lines intersect, forming right angles. All right, so two lines are said to be parallel if they have the same slope but different y-intercepts. And again, just to get on a much more basic level, parallel lines never intersect. So that kind of makes sense that if two lines have the same slope, they're going to have the same tilt. They just have to cross the y-axis at different places, and then you'll see two lines that would never intersect. On the other hand, two lines are said to be perpendicular if their slopes are opposite reciprocals of each other. So again, make sure your slope is in fraction form. If you flip it and change the sign and you get the other slope, that would mean those two lines are perpendicular. And just remember, perpendicular lines do intersect, but they intersect in such a way that they form right angles. Okay, so let's look at an example of parallel lines. So again, parallel lines. Let's say for line 1, I have y equals 2x minus 1. And for line 2, I have y equals 2x plus 4. So it's pretty clear to see here that if we look at the slopes in blue, Both of the slopes are the same, they're 2. The y-intercepts we'll look at in red. The y-intercepts are -1 and 4. So you can see pretty clearly that these two lines are parallel based on the definition, but let's look at that visually. Okay, so I'll do the Cartesian plane in black, and then we'll choose a color for each line. Okay, so let's say we do the first line, we'll call it line 1, we'll do it in blue, so I'll go over it in blue. And then we'll do line 2 in red. So remember everything you already know about graphing. We're going to graph these two equations using slope and y-intercept. So for the first equation, the y-intercept is at -1. Okay. And then from there, I want to apply my slope, which is 2. So if the slope is 2, that's really like 2 over 1. So I would go up 2 over 1, up 2 over 1. So there I have my first line. And again, you've really got to use your imagination and pretend this is perfect. If you're using graph paper, it'd be better. Now for the second equation, I have a y-intercept of 4. So I would go from the origin, I would go up 1, 2, 3, 4. And then from there, I apply my slope, which is 2. So I go up 1, 2 over 1, up. That one got a little out of line. Let's see. Up 1, 2 over 1, up 1, 2 over 1. So again, use your imagination, pretend this is graph paper and it's perfect, but you can see that these two lines have the exact same tilt. They have the same slope. So since they have that same slope, we can extend these lines forever in either direction and they will never intersect, okay? So you can see here that as long as you have the same slope, but different y-intercepts, you have two lines that are parallel. If the y-intercepts were the same, you would just have two equations that graph the same line. So that doesn't really count. So same slope, different y-intercepts. Now let's look at perpendicular lines. We'll do the same thing. Line 1 we'll do in blue. So let's say that the first equation is y equals 3x minus 1. Second equation we'll do in red, and we'll say that the second equation is y equals -1/3 x plus 2. Now you can see here, I'm going to do the slopes kind of off to the side. So the slope for the first equation is just 3. And we'll think of it as like 3 over 1. For the second equation, the slope is -1/3. So you can see that these two slopes are opposite reciprocals of one another. You flip the fraction, you change the sign, you get the other slope. Okay, so now let's look at this graphically. Okay, so we'll graph the first line, like I said, in blue. So the first line has a y-intercept of -1, and then the slope is 3, or 3 over 1. So that tells me I can go up 1, 2, 3 to the right 1, up 1, 2, 3 to the right 1. So I've got my first line right here. I'm going to try to graph it as nice as I can. All right. And then for the second line, we'll do it in red. I have a y-intercept of 2. So I'm going to go up 2 from the origin. And then I'm going to apply my slope, which is -1/3. So I'm going to go down 1 and then to the right 1, 2, 3. I'm going to go down 1 and then to the right 3. So I've got these lines right here. And there you have it. You can see, again, pretend this is graph paper and these were not drawn freehand and they're just perfect. But you can see that these angles right here, Like this right here is definitely a right angle. This is a right angle. This is a right angle. This is a right angle. So you can see these two lines really do intersect, forming right angles. And just like the definition on the previous slide said, the slopes really are opposite reciprocals of one another. Okay, so now on this slide, I want to look at what happens if we just look at equations. Can we tell if the two lines are parallel, perpendicular, or neither? So let's look at one example of each, I guess. Whoops. So determine if the pair or the pairs of lines are parallel, perpendicular, or neither. So neither would just mean you have random slopes, random y-intercepts, there's no connection between them. So let's look at the first example. So for the first example, I have 4x plus y is 1. 4x plus y is 1. And then I have x minus 4y is negative 8. So what I'm going to do is I'm going to take both equations, I'll solve them for y, and then we can compare the slopes, okay? So for the first equation, I have 4x plus y equals 1. I need to subtract 4x from both sides, and I get my equation in slope-intercept form. And what's so nice about slope-intercept form is we can see what the slopes are, okay? So for the first equation, I subtract 4x from both sides. I get y equals negative 4x plus 1. The coefficient of x is negative 4. So let's look at the second equation. So for the second equation, I get x minus 4y is negative 8. I'm going to start by subtracting x. That's going to give me negative 4y equals negative x minus 8. I'm going to divide each term by negative 4. And that gives me y equals positive 1/4 x plus 2. All right, so we're looking at these two lines right here. Well, for the second line, the coefficient of x is 1/4. So now my question would be, is there a connection between these two slopes? Well, the slopes are not the same, so we can automatically say these are not parallel. But are they opposite reciprocals? Well, one slope is negative, one slope is positive, so that's good. And then if I look at negative 4, so like if I look at my slope of negative 4, that's really like negative 4 over 1. And if I find the reciprocal of that, I would get 1/4. So these two lines, the slopes are opposite reciprocals. So I would say these two lines are parallel. Not parallel, Lord have mercy, perpendicular. All right, let's look at another example. So for the next example, let's say that we have 3x minus y equals 2 and 3x plus y is 1. So just like the previous example, I'm going to take each equation, I'm going to solve for y. So I have 3x minus y is 2. I'm going to subtract my 3x. That's going to give me negative y equals negative 3x plus 2. Now, hesitate from stopping at this point, because at this point, you're not totally solved for y. We have officially solved for y when we have a single positive y. So what I'm going to do is multiply the entire equation by negative 1. And that gives me 1y equals positive 3x minus 2. Now, looking at this equation, the slope is 3. Now, for the second equation, I had 3x plus y equals 1. I would need to subtract 3x. That leaves me with y equals negative 3x plus 1. So solve for y. The slope here is negative 3. So right off the bat, it looks like the slopes are 3, but one's negative, one's positive. So again, the slopes are not exactly the same. That would tell me that these lines are not parallel, they're not perpendicular. You do have opposite signs, but you don't have the reciprocal thing happening. So these are just two random lines, okay? Be especially careful with this equation right here because of that sign issue. If you didn't deal with the signs in this one, it would very much look like you were dealing with parallel lines, but in this case, you're not. This one's a little tricky, but there's no actual connection between these two lines. They're just two random lines hanging out there in space. All right, one more example. Let's say that we have 2x minus 3y is 6. And then we have y equals 2/3 x plus 4. Well, for this one, for the first equation or the second equation, it's already in slope-intercept form, and we can see that the slope is 2/3. But I do need to take that other equation, the 2x minus 3y is 6, and I need to go ahead and solve it for y, and then we'll go from there. So to solve this for y, I want to subtract 2x. 2x is canceled. I'm left with negative 3y is negative 2x plus 6. The negative 3's cancel. Or, well, I need to divide everything by negative 3 first. And then the negative 3's on the y's cancel. And then negative 2 divided by negative 3 is positive 2/3. And then positive 6 divided by negative 3 is negative 2. So now looking at the two equations that I've got boxed in, the first one has a slope of 2/3. The second one has a slope of 2/3. So automatically we're like parallel, but you also have to check the y-intercepts. So for the first equation, the y-intercept is 4. For the second equation, the y-intercept is negative 2. So we are good. We can say officially and with confidence that these two lines are parallel. So far, you just need to know by definition the difference between parallel and perpendicular lines. Again, parallel lines have the same slope, different y-intercepts. And that kind of makes sense because on a basic level, two lines are parallel if they never intersect. So if lines have the same slope, they're never going to intersect. For perpendicular lines, we know that perpendicular lines have slopes that are opposite reciprocals of one another. So as long as your slope is in fraction form, if you flip it and change the sign, and that gives you the other slope, you've got perpendicular lines. And remember, graphically, perpendicular lines intersect forming right angles. So we did an example of each. We looked at two parallel lines, and you can see that by having the same slope and different y-intercepts, you do have two lines that won't intersect. And then we looked at an example of perpendicular lines. You can see once you graph them that they really do intersect, forming right angles, but also the slopes of these two lines really were opposite reciprocals of one another. We then looked at just pairs of lines, and we determined if the two lines were perpendicular, parallel, or neither. Okay, so next up, what I want to do is I want to look at finding equations. Okay, so what we're going to do here is find the equation. Let me go back to black ink. So we're going to find the equation of the line parallel to the equation given and that goes through a given point. So basically, we're going to be given an equation. We want to be parallel to that equation. That means we want to share the slope with that equation, but we have to go through a very specific point. Okay, so for the first example, we want to be parallel to y equals 3x minus 4. And we want to go through 4, negative 2. Well, here's the deal. We can already see that the slope of the equation given is 3. If we want to be parallel to that equation, we want to have the same slope, different y-intercept, okay? So we're going to go ahead and just steal the slope of 3. But remember, we want to go through the point 4, negative 2. And the way we're going to figure all of this out is we're going to use that point slope form from the previous video. So we're going to let this right here be x1, y1, and then of course this is m. So I'm going to plug in what I have. So I'm going to take y minus y1, which is negative 2 from the point given. I'm going to steal the slope from the equation that was given, and then I'm going to multiply that by x minus x1 from that point given. I'm going to do some simplifying. Y minus -2 is really y plus 2. And then 3 times x minus 4 is really 3x minus 12. Now, this question doesn't specify if you should write your answer in standard form or slope-intercept form. I'm perfectly happy with slope-intercept form, so I would subtract 2 from each side, and I get y equals 3x minus 14. Now, what this equation is, this equation y equals 3x minus 4 is parallel to y equals 3x minus 1, and it goes through the point 4, -2. All right. So it's a little bit of work, but luckily you had an equation that was already solved for y, so that definitely made it a little bit easier. If this equation y equals 3x minus 1 had not been solved for y, there definitely would have been more work involved, okay? So all you would have to do is go ahead and solve it for y yourself. So let's say for this one, we're going to be parallel to 2x minus y plus equals +5, and we're going to go through 7, -5. All right, so in this particular case, we want to be parallel to 2x minus y equals 5. So what that means is we want to share the same slope as the equation 2x minus y is 5. So what we have to do first is figure out what that slope is. So I'm going to take 2x minus y is 5, and I'm going to solve it for y. So I'm going to start by subtracting 2x. So that's going to give me -y equals -2x plus 5. I'll then divide by -1 on both sides. So really, I'm just going to divide every single term by -1. That's the easiest way to get everything nice and simplified. So what I have here is y equals +2x minus 5. So what's the slope? Well, the slope is 2. So since I want to be parallel to this equation, I want to use the slope of 2. So we're going to have this point right here, x1, y1, and then we have the slope of 2, and we're going to plug all of that into y minus y1 equals m times x minus x1. So y minus y1, well, y1 is -5. M, we're going to steal it from the other equation, it's 2. And then let's see, I take x minus x1, which is 7. I'm going to clean things up a little bit. I get y plus 5 equals 2x minus 14. And then I'm okay with this being in slope-intercept form, so I'm going to subtract 5 from both sides. And I get y equals 2x minus 19. So this right here, this final answer right here, this is the equation of the line that is parallel to 2x minus y equals 5, but it also goes through the point 7, -5. Cool? All right, so for the next slide, what I want to do is exactly the same thing, but we're going to look at lines that are perpendicular. So we're going to find the equation of the line that goes through the provided point and is perpendicular to the given line. All right, first example. Let's say that we want to be perpendicular to y equals -4x minus 2, and we want to go through -4, -1. Okay, so what we need to do first is look at the slope of the line given. So the line given has a slope of -4. Now, if we go back to the original definitions, two lines are said to be perpendicular if their slopes are opposite reciprocals, okay? So what is the opposite of a negative? Well, it's a positive. And if I were to write -4 as -4/1, I could flip it to get 1/4. 1/4. So we're interested in the line perpendicular. So we're going to use a slope of positive 1/4. We then have this ordered pair, x1, y1. Well, what am I going to do with all of this? I'm going to plug this into point slope form. All right. So when I plug this in, I'm going to get y minus y1, which is -1. M is positive 1/4. Now remember, we're not using the same slope. We're using the opposite reciprocal of the given slope. And I'm going to multiply that by x minus x1, which is -4. Okay. So I'm going to do some just cleaning up of the signs. So when I subtract a -1, it just becomes +1. And when I subtract -4, it just becomes +4. All right. I then want to distribute. So I get y plus 1 equals 1/4 times x. And then 1/4 of 4. Well, 1/4 of 4 is 1. I'm multiplying a positive and a positive. So I'm just going to get +1 here. Now I need to subtract 1 from both sides, which is fine. And I get y equals 1/4 x. The ones end up canceling. Now, if you go back a few videos, you'll remember that when you have an equation that has just a y term and just an x term, but there's no plus or minus a constant, that just means that the line goes through the origin, which is fine. So the equation y equals 1/4 x is perpendicular to y equals -4x minus 2, and it happens to go through the point -4, -1. All right. Let's do one more example like this, and then of course we'll talk about horizontal and vertical lines and how that works. So for this one, we want to be perpendicular to y equals -2x plus 5, and we want to go through -2, -5. Okay, so looking at the equation that's given, we have a slope of 2. It's in slope intercept form. We just have to look at the coefficient of x. So the slope is -2. Now for the line perpendicular to that, we want to write the reciprocal of 2. So think of 2 as 2/1. We flip the fraction, we get 1/2. And then we want to change the sign. Since the original slope is negative, we want our slope to be positive. So we're going to use the slope 1/2. Now we have x1, y1 right here. And what we're going to do with all of this is just like we did in the previous examples, we're going to plug it into point slope form. So y minus y1, where y1 is -5. M, we're going to remember, we're not going to use the slope of 2. We're going to use the opposite reciprocal of 2, which is positive 1/2. Or we're not going to use the slope of -2. We're going to use the opposite reciprocal of that, which is positive 1/2. And I'm going to multiply that by x minus x1, which is -2. So I'm going to clean up my signs. So I really just have y plus 5 equals 1/2 times x plus 2. And then I'm going to distribute 1/2 through the parentheses. I get y plus 5 equals 1/2 x. And then what is half of 2? Well, it's just 1. And since 1/2 is positive and 2 is positive, we're going to get positive 1. And then the last thing I need to do is just solve for y. So I'm going to subtract 5. And I end up with y equals 1/2 x minus 4. And that's it. So y equals 1/2 x minus 4 is the line, it's the equation of the line that goes through the point -2, -5, and is also perpendicular to y equals -2x plus 5. Okay, so now we've looked at just what parallel and perpendicular lines are. We looked at examples of 2 lines that are parallel, 2 lines that are perpendicular. We looked at pairs of lines, and we determined if these pairs of lines were parallel, perpendicular, or neither. We found equations of lines parallel to other lines. And now we have found equations of lines perpendicular to other lines. So the last thing I really want to do is look at parallel and perpendicular lines as far as horizontal and vertical lines are concerned. So horizontal and vertical lines. Okay, so vertical lines are parallel two other vertical lines. Wow. Did you see what I did there? Jeez. Vertical lines. Now, horizontal lines are parallel to other horizontal lines. Okay? So vertical lines are parallel to vertical lines, horizontal lines are parallel to horizontal lines. Now, when it comes to perpendicular lines, vertical lines are perpendicular to horizontal lines. And I'm going to go ahead and write the horizontal lines are perpendicular to, but it's basically the same thing. If vertical lines are perpendicular to horizontal lines, then horizontal lines are perpendicular to vertical lines. And then I'm going to also do a recall or a recap. Vertical lines are of the form x equals a, where that looks crazy. X equals a, where a is a real number. And then horizontal lines are of the form y equals b, where b is a real number. So you need to kind of remind yourself of what the equations look like. And then also remind yourself that vertical lines are of the form x equals a, where a is a real number, because vertical lines have to touch the x-axis, but they cannot touch the y-axis. So that's why they just have an x in the equation. Horizontal lines have to go through the y-axis, but they cannot touch the x-axis. So that's why they only have a y in the equation. Okay, so that's kind of like your recap of horizontal and vertical lines and how that ties into parallel and perpendicular lines. And now let's look at a couple of examples. So we're going to find the equation of the line with the given information. Okay. So first up, I want to be parallel to x equals 5. And I want to go through to -1. Well, what lines are parallel to vertical lines? We have a vertical line here because we've got the x equation and no y. And so what are vertical lines parallel to? Well, they're parallel to other vertical lines, okay? So then we know this is vertical, and it has to go through this point. The only x value we have is 2, so we would get the equation x equals 5. Now, what if I changed it and I said I wanted to be perpendicular to x equals 5, and I still wanted to go through to -1? Well, if we go back a slide, vertical lines are perpendicular to horizontal lines. Okay, so we know this is vertical right here. So this is vertical. Vertical lines have to have an x. Okay, so if we were going to be parallel to this, we would want to do x equals 2 like we did in the previous example. But in this case, we want to be perpendicular to this. So we're looking for the horizontal line through to -1. So the horizontal line is going to have to go through the y-axis. And so the equation would end up being y equals -1. Okay. Now we're going to repeat the process, but we're going to do horizontal to begin with. So I want to be parallel to y equals -3. And I want to go through the 0.54. Now, this is horizontal. I know it's horizontal because it has a y and it has to go through the y-axis. The only y value given is 4. And remember, parallel lines have the same slope. So if we go back one slide, we know that horizontal lines are parallel to other horizontal lines. So here I would just get the equation y equals 4. Now I want to be perpendicular to y equals -3 and still go through 4. Well, if we look at the previous screen, horizontal lines are perpendicular to vertical lines. So we're looking for the vertical line that goes through 4. So vertical lines have to have the x coordinate. So the equation here would just be x equals 5. So like I've said in previous videos, horizontal and vertical lines, it's not that there's hard work involved. You almost never have to do much in the way of calculating, but you have to have a really firm understanding of what a horizontal line is, why vertical lines have the x, why let me start that over. Why vertical lines have the x, horizontal lines have the y's. You need to understand their slopes, their intercepts, how they graph, what a table of values would look like. And now you need to understand what parallel lines are as far as vertical. So like, what is vertical parallel to? Well, other vertical. What is horizontal to? Well, other horizontal. You also need to know how this works with perpendicular lines. What is vertical perpendicular to? Well, horizontal. That means that horizontal lines are also perpendicular to vertical lines, okay? So this slide right here, make sure this makes sense, okay? Now, brief recap. Parallel lines, same slope, different y-intercepts. Perpendicular lines have opposite reciprocal slopes. We looked at that graphically. We looked at just equations and determined if lines were parallel, perpendicular, or neither. We found parallel equations. We found perpendicular equations. Then we talked horizontal and vertical. So that's a pretty good overview of parallel and perpendicular. You know, we could certainly do more examples of determining if two equations are parallel, perpendicular, or neither. We could look at more graphs, we could look at more equations, but that's the overview, okay? So that's the 10th video in the series. I think the last video in the series is going to be obviously the 11th video, and it will be on graphing linear inequalities in two variables. So at this point in time, you should already be familiar with just linear inequalities in one variable. So we're going to take that idea of linear inequalities in one variable and we're going to merge it with graphing equations in two variables. All right. So best of luck.